Well, it's another day, students, and here we're going to talk about our 15th video on circles. And there are two theorems today that are going to be in the homework. The first theorem is called the secant segments theorem, and the second one is called the tangent secant segments theorem. So what you may want to do is you may want to copy this down, and then I'm going to explain them to you, and we'll go from there. Okay, so you're back. Hopefully you have these things copied and set up. And the secant segments theorem says this: if you have two secants drawn to a circle through an exterior point, then their product of certain segments are equal, and those segments are the whole secant and what your book calls an external secant, BC, and it's sort of the beginning part of the secant. And if you multiply those two together, then it'll equal the other secant times its external secant. Now, why is this so? The reason why it's so is if you draw these two lines, that makes two triangles, triangle ACE and triangle DCB, and it turns out that those triangles are similar. Now, why are those triangles similar? Well, really quickly, they both have angle C, and so that's equal to it. And then this angle and this angle, angle A and D, are equal because they are both equal to the same arc, or half of the same arc, BC. And because that is true, the triangles are similar, and therefore we can set up correspondences. And so if you'll remember, it's triangle AEC and triangle DBC. And so the segments AC, that corresponds to the segment DC, and the segment BC, or excuse me, EC in the first triangle corresponds to segment BC. And if you remember, we were comparing different parts of each triangle, the corresponding parts. Well, if you now look at this and you cross multiply, then you're going to get what we have up here. And that's why this theorem is true. So that takes us to the next theorem. And in this case, we have a tangent and a secant drawn from an external point B. And in this case, that means that AB squared is equal to BC times BD. So the secant segment times the external secant segment, and then the tangent segment squared. So why does that actually work? Well, in the same way that we've done before, we're going to make some triangles, and it turns out that these triangles are going to be also similar. Now, it's slightly trickier, but it's not a lot trickier to show that they're similar, and then you're going to set up ratios like above. So why are they similar? The triangles we're looking at are triangle A, B, C, and triangle D, B, A. And so if you have those two triangles, then what happens is angle B is equal to angle B. And then what we would like to do is we'd like to show that angle A and angle D are the same. Well, how can you do that? Well, look at this arc. First we have AB is tangent and AC is a chord, and so they're half the measure of this arc. And then angle D is an inscribed angle with that arc, so it's half the measure of the arc. So therefore those two angles are equal. Once they're equal, the triangles are similar, and now you can set up the formulas for doing this. And the last part of the formula is BC. And so now once you set those up, again, you can cross multiply and we end up with what we started with. So that's the basics. Let's look at a few problems. So here's a problem set up that we can do. I want you to give it a shot yourself and see how you do. The theorem you're going to use is the secant segments theorem. And I want to see if you can set this up appropriately. So give it a try. I'll pause for a couple of seconds and then come back and we'll give it a shot and see how we do. So here we are, we're back, and what I can see right away by looking at this diagram is I have a secant EC and a secant AC. Therefore, and I want to find a segment X, and so therefore I know that I'm probably going to use the secant segments theorem. And so what I want to do first is I want to actually just set up what the secant segments theorem says. And the secant segments theorem says that the secant AC, so AC times its external secant segment BC is equal to the segment EC times its external secant segment DC. And now that I have set that up, and this is what you want to do all the time, I can fill in things. So what is AC equal to? Well, it's equal to 8 plus 4, so that's 12. What's BC equal to? That's right, it's 4. What's DC equal to? That's 3, and now we come to the tricky part. What's EC? Well, as you can see, it has two pieces, and we have to add them together, so we write x plus 3. And now this gives us an equation which we can solve for x. 12 times 4 is 48. 3 times this, using distributive property, I get 3x plus 9. Subtract 9 from both sides, and I get 39 equals 3x. And if I divide by 3, I get 13 is equal to x. And if these had had units, then I would have tacked on the units to 13. So that's the first problem. So as you can see with this problem, we'd like to find x as well. And this one, as you can see, is a tangent line and a secant line. So we're going to use the tangent secant segments theorem, which, if you write out what that is, you should have AB squared equals DB times CB, the secant times its external secant. And if you fill that in, you should get 9 squared equals 5 plus x times 5. And now you can proceed to solve. 81 equals 25 plus 5x. Subtract 25 from both sides. And you end up with 56 equals 5x. And then when we divide by 5, we end up with 56/5 equals x. And it's perfectly okay to get a fraction as well. And that's our solution on this problem. So here's another problem, slightly more complicated. If you like, you could label each of these points here. So you could write it out in formula, or if you feel like you got it, you could just write it out in the formula for the external secants theorem right away. So give it a shot and then let me know what you think about it. So this problem will be the external secant times the secant. So you're going to have 8 times x plus 4. And that's going to equal this external secant times the whole secant. Actually, I did that wrong. So let's pause for a second. Do you see what I did wrong? Let me scratch this out and see if you can fix it. It's the external secant right here, which is 8, so that was correct. But then I had to multiply it times the whole secant, but that's actually not just x plus 4, it's x plus 4 plus 8, so it's x plus 12, and that was my mistake. So now we can do the other side. And that's the kind of mistakes you can make, so you have to pay attention to those, and you want to be aware of those when they occur. So the next one, we can see that the external secant segment is x, but then what's the whole segment? Well, it's going to be 2x plus x, which is 3x. And so now here's our problem, and we can proceed to solve. So by distributive, we get 8x plus 96. And over here, we get 3x squared. And as we can see, this is going to be a quadratic equation. So we want to get everything with the x squared. So we go 0 equals 3x squared minus 8x minus 96, subtracting those from both sides. And this, then, is a problem we have to factor to solve, or use the quadratic formula if it doesn't factor. So I took a little time to think about this. Have you figured out what you need to put right here and right here so that when you multiply them you get negative 96, but when you add them you get negative 8? So give that a shot. If you haven't done factoring in a while, you might be a little rusty. If you tried it a couple of times, you might have figured out that this one does not factor. And since it doesn't factor, that means you have to use our old friend, the quadratic formula. So I'll just move this up here. And the quadratic formula, if you remember, is minus b plus or minus the square root of b squared minus 4ac over 2a, and that's how you solve for x. Now, the problem with a problem like this, and the challenge, a is equal to 3, b is negative 8, and c is negative 96. The problem with or difficulty with a problem like this is that, as I've told you all year, everything you learn in math will be used again, and so you have to remember things even though you may not have used them for a while. And so one of the reasons we do these videos is to remind you that certain things can happen. So you're going to have to watch out on your homework for problems that are going to require quadratic formula. Now, while I was talking to you, I went ahead and filled this out. So I'm going to shrink that just a little more so I can fit it in on the paper. But once I then begin to multiply that out, I will get 8 plus or minus square root of 64 minus, that'll actually be a plus because of the two negative signs, 12 times 96, which is figuring 1152 all over 6, and our answer is 8 plus or minus the square root of 1216 over 6. And then you would have to work to simplify that. But if you can get it here, then you could type it into a calculator. You could type 8 plus square root of 1216 in parentheses, and then hit divide by 6, and then you could do 8 minus square root of 1216 divided by 6. And you'll notice that this is a positive answer and this one will be negative. And based on our diagram, the only answer we can choose is the positive one. And so the approximation, just so you know it, I'll do it here on my own calculator. I end up with the number 7.15, and that's the approximation. Okay, and that's a much harder problem with that type of thing. So good luck on this assignment. This video is a little longer. I apologize for that, but these particular problems have some harder things. I'll show you some other things in class tomorrow when we go over this, so I can show you a few more ways to deal with this kind of problem.